For ionization energy, we need to know what an ion is. An ion is an atom that has a positive or a negative charge to it, and that means that it has either gained or lost electrons. Ionization is any process that forms an ion, whether it's positive or negative. Ionization energy, or IE, sometimes with a little 1, is the energy required to remove one electron. Okay, so we have electrons in the energy levels. The outermost electron, the valence electron, this would be sodium. The energy required to take that electron off of the atom, that is our ionization energy. What happens to ionization energy as you go across left to right, across the period? Okay, I'm going to look at my diagram down here. So each of these little sections that's divided off is showing us a period on the periodic table. So this is period 1, it's just hydrogen and helium. Period 2, right here, what's happening as you go left to right across that period? What about period 3, from left to right? What's going on here? Well, obviously, it's increasing. Okay, some of them are weird, yes. Like right here, this is not an increase. This actually goes down. But overall, the trend is that you're going from low to high across each period on the periodic table. Period 4 gets complicated because we have those transition metals in there. Okay, so what's going on? Let's write that down. As you go left to right, the ionization energy increases. So it increases as you go left to right. Why is it harder? Why does it require more energy to take electrons away from the atoms on the right? This has to do with Coulomb's law. So over here, these atoms, known as the noble gases, are the highest ionization energies because they are the smallest. So since they're the smallest atoms, that means, going way back to our Coulomb's law, the smallest atoms, so the lowest R value, is actually going to have the greatest. So the lower R equals a greater force of attraction. And if we're trying to take the electrons away, we have to overcome that force of attraction. So a small radius means higher ionization energy. Let's write that down. As you go across a period, the number of protons increases and the atoms get smaller. With the smaller distance and the greater nuclear charge, valence electrons are held with a stronger Coulombic force. They're just held with a tighter force. And therefore, they require more energy to remove, and that means they have a higher ionization energy. Opposite for as you go down a group of elements. So let's look down here. As you go down, this is helium, neon, argon, krypton, xenon. So as you're going down the noble gas group, you can see that the general trend in their ionization energy is to decrease. And that's because helium has 1 energy level with its 2 electrons. Neon has 2 energy levels, and then argon has 3. So as they move farther and farther from the nucleus, it's easier to take them off of the atom. Okay, let's write that down. Ionization energy has a life of its own. Sorry about that. Decreases as you go down a family. And the reason is because the atoms get larger moving down a group. The electrons are farther from the nucleus. Thus, according to Coulomb's law, they require less energy to remove. They're easier to take away because the atoms are bigger. Second ionization energy you guys might see is just the energy required to remove a second electron. So once we remove this first outer electron, if we want to remove another electron, that energy is the second ionization energy. Which group of elements has the highest ionization energy, and which group of elements has the lowest ionization energy? Let's see if you guys can answer these questions. All right, the highest ionization energy is the top of each of these periods. So these are the noble gases. I'm just going to put group 18. Which group has the lowest? So if I look, what's the lowest ionization energy in each period? It's lithium, sodium, potassium, rubidium. Those are all the alkali metals, which is going to be group 1. Okay, those have the lowest. They are the easiest to remove because they're the biggest atom in each period. Which atom has the greater ionization energy in each pair? Boron compared to carbon. We have to look at where it's at. Boron is farther to the left, so boron is here. Carbon is here. Boron is bigger, so it's going to have a lower ionization energy. And that means carbon actually has the greater ionization energy. Neon or krypton. Well, neon is right here. Krypton is down here. Krypton is a bigger atom. It's down on the periodic table. So if I look at where they're at on the periodic table, neon is in period 2 right here. Krypton is down a little ways in period 4. So krypton is bigger. It's going to have a lower ionization energy. Neon is smaller. It has the higher ionization energy. Okay, neon has the higher ionization energy. N or Ne, nitrogen or neon, which one has the greater ionization energy? N right here or Ne over here. Neon is smaller, therefore it has a larger ionization energy. It's closer to the right. So my answer is going to be neon. And last but not least, calcium or gallium. Calcium is a group 2 element. Calcium is right here. Okay, and gallium is way over here. Gallium is smaller. It's in the same period, so we know it's going to be smaller since it's closer to the right, and that means it has the higher ionization energy. All right, electronegativity is the attraction of an atom in a compound for an electron. How much does the atom pull on the electron? That's its electronegativity. So down here we can see the difference in the strength of the chlorine atom to the hydrogen atom. Chlorine has a greater pull on the electrons than hydrogen does. So we would say chlorine is more electronegative than hydrogen. It has a greater pull on the electrons. The trends down here you'll see are the same as ionization energy. As you go left to right, the electronegativity increases, and as you go down a group, the electronegativity decreases, and it's very similar reasoning. As the radius decreases, electrons get closer to the bonding atom's nucleus, and therefore they're more attracted because the smaller they are, the greater the force, right? Let's put small r equals high force. And then as you go down, as radius increases going down, the electrons are farther from the bonding atom's nucleus. So a greater radius equals less force of attraction. So the smallest atoms actually have the greater pull on the electrons, but we have another part in play, and that's the Q, that's the charge, Q1 and Q2. So remember, this was our coulombs, ignoring the K. I'm going to use this. You guys know this symbol? This means proportional to. The force is proportional to Q1 times Q2 over R squared. So the greater the nuclear charge, you're also going to have a greater pull on the electrons. So because of those combined things, fluorine is the most electronegative element of them all. It is a crazy reactive element that will steal electrons from literally anybody you put it with. because it is the smallest radius to charge ratio. It has the greatest charge. Fluorine has 9 positive protons in the center, and also it's teeny, teeny, tiny. So it has 9 positives, and they're very small, so it has the greatest attraction for electrons of all the elements. Electron affinity is very similar to electronegativity, except instead of it being in a tug-of-war in a compound, this is just you have an atom floating around. So you have just this, let's say it's hydrogen floating around, and how much does it want to gain an electron? Okay, so that how much does it want to gain an electron is very similar to the pull that it has on the electron. So you're going to see the exact same trends, and we're not going to write them down. For ionic radii, we need to remember that cations are positive. Cations are positive. Let's give them a little positive nose there. Okay. And anions are negative. The metal atoms tend to form cations. They're positive. So all the elements on the left of the periodic table tend to be positive. Nonmetals tend to form anions, which are negative. So the right side of the periodic table tends to form negatives. Why is that? And here is a summary of that. These have 1 or 2 valence electrons. So group 1 and group 2 have 1, 2. This one has 3 valence electrons. And remember, to have low energy, it wants 8. So these noble gases over here with 8 valence electrons, they're more happy than all the others, which means they're more stable. They're lower in energy. So they all want to get to this 8 valence electrons. Well, group 1 and 2 are very far from having 8. So they are going to give up their electrons and become positively charged. Same thing with group 13. It's going to form a +3 charge. It's going to lose its 3 electrons. Underneath those outermost electrons, they have a full shell. So they're going to lose the outer electrons. Over here, these nonmetals tend to form negative because nitrogen, for example, has 5 valence electrons. I'm going to put VE for valence electrons. And it's only 3 away from having 8. So nitrogen is going to do what it can to find an extra 3 electrons and become a full octet. So when it has its 8 electrons, it becomes more stable. Oxygen's group has 6 valence electrons. So it wants to gain 2 to have that full octet. So it's going to be -2. The halogens are almost always -1 because they are just 1 electron short of having their full octet. So they're going to do what they can to gain an electron and have the full S and P orbitals. And then the noble gases here. These guys already have their full octet. So they don't really want to form any kind of charge. They're going to have a neutral, 0 charge because they don't want to gain or lose anything. They're already happy. They're already stable. All right. So the elements on the left tend to lose electrons and become positive. That's what we saw up here. The atoms on the right tend to gain electrons, and that means they become negatively charged. As you go down, it's the same trend. So even if these were all charged, as you go down a group, the atoms or the ions are still going to get larger as you go down. Okay, and what I want you guys to know is that cations, the positives, are almost half the size. So they shrink, just losing 1 electron from here to here. Lithium has lost 1 minus 1 electron. Look at how much it shrunk from 152 picometers down to 60 picometers. So it's much, much, much smaller. Same thing with sodium. When it loses just 1 valence electron, it decreases by about half its size. When an atom gains an electron, it becomes, so this is from here to here, we're adding +1 electron. It doubles in size roughly. This is more than doubles actually. This is about doubles from here to here. So anions are almost twice the size of their neutral atom. Okay, so when they become positive, they get much, much, much smaller. +2 is an even larger change in size. And when they become negative, they blow up to twice their size. And that's because you have extra electrons over here. So these repel each other even more. So they push each other away, farther away. when you have an unbalanced positive and negative. The one less electron means the protons now outnumber the electrons and they pull them in even closer. So that's why you see such a big difference. And last but not least, the charge clock is just to help you remember the charges on the groups. So if we have group 18 here, group 14, 13, this is 1 and 2, this is the S block. And then we have 16, 17, 15, trying to spread them out evenly. So in these this is the group number. What is the charge in that group? 18 has no charge. They don't want to gain or lose any. Group 1 has a +1 charge. Group 2 has a +2 charge. Group 13 had a +3 charge. And then the halogens had a -1. The group 16 oxygens group was -2. Group 15 nitrogens group, -3. And guess what? These can be plus or -4, but what they really do is share electrons. So you're going to see covalent. You're not going to really see any kind of charge on carbon's group. It always wants to form a covalent bond. Okay, unless you have calcium carbide, which is highly explosive and super reactive. You guys can look that up. There's some cool videos. All right, that is it for today, and I hope you guys have a wonderful day.